This is a demo of how you can use different APIs to pull together a unified view of all the information on a particular subject. In the case, we're going to focus on drug targets. I'm going to start by logging into the demo with a simple query looking at one particular record. It's insulin, it's the top record, and you see here that we have information on insulin. Tissues, localizations, names, all that kind of basic information. You also see here the associated conditions, and by default this interface shows you the associated conditions where there is a drug for that particular disease that targets insulin, but we also have this concept of a putative target, that is that this particular target's associated with these other diseases, but there's no active drug going against it. Further down the chart, we've got information on specifically how many drugs by condition there are for this particular target, and two very important concepts at the bottom, what we call causative sources and condition risks. And this is where we show you what the evidence is that this particular target is in this particular disease, and what the evidence is that this target is a biomarker in that disease. On the other side, we have these, what we call the filters. This information can be used for a number of things. One thing that's very useful about the filters is they can be used to provide a kind of graphical view of what's going on in the result set, because there really isn't enough room to show 2,915 targets. This kind of gives you summary information, and here I can use the filters to provide an interesting graphical view of the target's hierarchy. I can also use the filters straightforwardly as filters, and so here I'm going to use the controlled vocabulary indexing that we have in the database to make sure that I am specifically talking about type 2 diabetes. I'm now going to show you a little bit about the query language that we expose. This interface is literally a face, if you like, on the top of the API, and the API exposes a very rich language that you can use to construct queries. Here I'm going to use that language to construct a query that specifically looks for diabetes type 2 drugs that have an active drug count more than 5. Using that kind of search enables you to be much more precise in your queries. I've got down to 6 results now, and I'm going to whiz down to a familiar target in type 2 diabetes, DPP4. And now I'm going to dive into that record and show the wealth of information that we have for DPP4 in the Targetsv2 API and in some of our related APIs. So I'm going to start with a summary of this particular target. So you've got information on the gene, the protein, about the target generally, its synonyms, connections to other databases, references, patents, all that kind of information is all presented here. You also see a bunch of links to public databases. So you can go from this and go and look at a particular record. Let's say we're interested in Ensemble, and you can very quickly whiz across and go and see what Ensemble knows about this particular target and flip back. Next tab is looking at the drugs and where they are for each particular disease. So what we have in the Targetsv API is this listing of by each indication which drugs are at which phase, and it enables you to get a real feel for how mature this target is in a particular indication. So in diabetes type 2, you can see we have a fairly full pipeline, and we have each of these squares represents one drug, and if you are interested in the details of any one drug, I've just done a little pop-up that goes into the database and pulls out information on that particular drug. DPP4 is also a biomarker in a number of indications, and this information is also in the Targetsv API. You can see here what those diseases are, the validity of that biomarker. So you can see here that the biomarker has been used in early and late studies in humans, so it's a relatively mature biomarker. Moving on, we're looking at the variants. Here you can see the variants associated with this particular target, and you can see, for example, that this particular polymorphism is responsible for higher risk to plasma triglyceride, and you can see the p-values there from our database. Looking at the interactions, you can see DPP4 is involved in a lot of interactions. On the left-hand side, I've grouped all the incoming ones. On the right-hand side, all the outgoing ones. And there are a lot of incoming interactions to DPP4, pages of different things interacting upstream. But you also see some upstream events like phosphorylation and transcription regulation. So you've got that sense of the target in its context, in its biological context. To get more biological context on the target, you can look at the pathways that it's involved in. And this is a point at which we are combining information from the Targets API with the maps that are in the Omics API. So I'm going to pull up a map from the Omics API, and this gives you the context of the target within a particular pathway. Another thing that people are interested in when they're looking at a particular target is what molecules interact with that target, and what are the experimental pharmacology results. So here we are pulling information from the drug design API to show the specific experimental results. So I'll focus down on one particular subset, and here all I'm basically doing is exposing those filters in a slightly different way. Bring the KIs together. Let's have a look at the structures, because chemists like to look at structures. So this is now then pulling the chemical structures from our databases and just populating this as a simple kind of SAR table. And here you see all of the different structures. You can see all the different results, and you can see this little pop-up here that tells you what the reference is, and you could then create a link from that to the PubMed article or whatever. I'm going to get down and pick the last one in the set. Just got 3 KI values, and pull up the drug record. This is the drug record. It's a smaller version of the drug record that we have that's in the Targets API. We have a fuller version in the drug design API, which I'll show in another video. But here's the summary information on vitelgliptin, and you can see here the trials that vitelgliptin is involved in, and that is within the Targets API. And so I'm going to go and pull all 245 trials that vitelgliptin is involved in. So here they are. These are the trials of vitelgliptin, and you see the summary information that is in the Targets API: title, indication, protocol, and outcomes. If you want further information on that particular trial, what you can do is then link to the clinical API and pull the full clinical API record. So I'll hop back to the summary here of the target and do another thing that a lot of customers are interested in, which is to look at pharmacology that comes from other sources. And here I've mashed up Chembl using the Chembl API. And again, because I have in our API all of the public identifiers of this particular target, it's very easy to reach out and mash up other data sources. And I'll just quickly show one record. So you can see you can navigate to and fro from different databases and pull together information so that people can really kind of browse the information that exists on that particular target and stay within one interface.